All right, good morning. This is Pre-AP Pre-Cal, and we are going to be sending lessons out for the next couple of weeks. Hopefully we see you in May, but we need to move on because we've got to get you guys ready for calculus for next year. So here we go. I sent a packet of papers to you, and I don't know if you had the chance to either pick them up or download them, but it starts off with the inverse pre-cal work here and goes into inverse trig. And then we get to our basic trig identities, and this is where I'm going to start today. We'll come back to the inverse papers later. We're going to start with the basic trig identities. This is very exciting because this is the part where you get to find out why you learn Pythagorean's theorem. So let's just start with the information that's in the box. The identity is an equation that's true for all values. For instance, difference of squares. A squared minus b squared is a plus b, a minus b, all the time because it's always true. So there are a number of identities that connect the trig functions. One thing you're going to find that's a little frustrating in this section is you're not solving for values, you're just kind of rearranging pieces, and you have to understand how to rearrange the pieces. And for students, sometimes that's a little frustrating because usually you're solving for, x equal 2 or whatever it may be. That not so much the case this time. But we'll get to that in just a few minutes also. So there are a number of identities that can connect our trig functions, and these identities are options for substituting, and this is your key word here because sometimes you're going to have to substitute. You won't have enough information to work with what you're given, so you're going to have to think what's an alternative path that I could take to solve this problem. So again, we're in our unit circle. R is 1, which it will be from here on out, and P is a point on the unit circle. Find the trig ratios. Well, remember, sine is y over r, and in this case, r is 1. So sine turns out to be just our y value. Cosine is x over r. Again, r being 1, cosine is x. So as I'm looking at this point, this triangle that I've created, this is my x value. But now that we're older mathematically, we're going to call it cosine. This is my y value, but again, we're older mathematically, so now we're going to call it sine. Tangent, of course, is y over x, or in trig, sine over cosine. Now, our reciprocal functions, cosecant is going to be, of course, 1 over, r over the y value, which is going to be 1 over sine. Secant is r over our x value, or 1 over cosine. And then cotangent, of course, is x over y, or cosine over sine. Now, if we go back to the equation of the circle, and you may have to go back in your notes to find this, but you may remember x minus h squared, y minus k squared is r squared. Well, if h and k are 0 and 0, we end up with x squared plus y squared is r squared. And in this case, our r value is 1, so x squared plus y squared is 1 in our unit circle. Now we're going to revisit that in just a moment, so just put that aside for now. Okay, reciprocal identities. When we're speaking of that, we're talking about the reciprocal. So, of course, one of my reciprocal identities is cosecant, which is 1 over sine. Another is secant, which is 1 over cosine. And then, of course, cotangent, 1 over tangent. Now, when we're talking about our ratio identities, we're talking about tangent, which is sine over cosine, and its partner cotangent, cosine over sine. Okay, this is nothing new. This isn't anything you don't already know. It's just something we need to revisit as we move forward. All right, so let's turn the page. A couple basic rules. These single term identities can be squared to form new identities, which means I can square everything. For instance, if I have tangent squared theta, I know it's sine squared theta over cosine squared theta. I can square everything. Cosecant, same thing, and it doesn't really matter what your function is or your trig ratio. Cosecant squared is going to be 1 squared over sine squared, which of course is just 1 over sine squared theta. Okay, here we go. Here's the fun part. Pythagorean identities. Okay, so Pythagorean's theorem, we've known that for years. A square plus b square is c squared. Well, remember, we are dealing in right triangle trigonometry here. So we have, if look at the front of the page, a turns into x, b turns into y, and c is r. But what do we know about the unit circle? R is always 1. So therefore, we have x squared plus y squared is 1. Okay. But again, we are older mathematically, and we're not going to call x x. We're going to use our other term, and we're going to call it cosine squared theta. Well, if I call x cosine, I'm going to be referring to y as sine squared theta, and it equals 1. I can't impress upon you enough how important this is. This is so important, we refer to it as our granddaddy equation. This is huge. Cosine squared plus sine squared equal 1. It's simply Pythagorean's theorem. A squared plus b squared is c squared. But now that we're in trig, x is cosine, y is sine. So cosine squared plus sine squared is 1. Okay, there are some variations of this. So let me get a clean piece of paper here. You don't have to memorize them, but you have to memorize how to find them. And the nice thing is, it's all right here in the granddaddy equation. So what do I mean? Well, let's just say we decided to divide everything in the granddaddy equation by cosine squared. All right. So cosine squared divided into every term. Well, cosine squared divided by cosine, of course, any number divided by itself is 1. Sine over cosine. That's familiar. Oh yeah, that's tangent. So I have tan squared. And 1 over cosine is secant. So we end up with secant squared theta. So there's one of your variations of the granddaddy identity. Cosine squared plus sine squared is 1 divided by cosine gives you 1 plus tan squared is secant squared. Again, you don't have to remember this, but you have to know how to find it. Okay, well, that being said, how do we find the second formula that equates? Well, if I divided everybody by cosine squared, what's my other alternative here? It's all right there at your fingertips. So, sine squared? Let's do that. So I'm going to divide everybody by sine squared. And again, you don't have to come up with this. All you have to do is look at the equation. Cosine is right there, sine is right there. Just divide everybody by cosine squared and then divide everybody by sine squared. All right, so here we go. Cosine squared divided by sine squared is cotangent squared. Sine divided by sine, and well, of course, any number divided by itself is 1, and 1 over sine is cosecant squared theta. So again, you don't let's back up. My granddaddy equation is a squared cosine squared plus b squared is c squared. X squared plus y squared is r squared Cosine squared plus sine squared is 1. All right? The other two that come off of this, let me leave this up here so you can see it while I'm writing. All right, in your head, cosine divided by cosine is 1. Sine divided by cosine is tangent. And 1 divided by cosine, secant squared. So there's your first identity that comes off the granddaddy equation. All right? What's the next one? We divided the granddaddy by cosine squared. We can divide it by sine squared. Great. Cosine divided by sine, cotangent squared. Sine divided by sine, 1. And 1 divided by sine, cosecant squared theta. So there is your granddaddy equation and the two equations that go with it, two identities that go with it. I call it a granddaddy equation, the granddaddy identity, whichever. And again, for those of you moving on to calculus, you will hear this term all the time. I will constantly say, think about your granddaddy, think about your granddaddy, think about the granddaddy, because this slips into our calculus equations so often, and sometimes we have to change the format. All right, lock this in. You must remember cosine squared plus sine squared is 1. Okay, it's Pythagorean's theorem, not a big deal. Well, how do I find the other two identities? Divide everybody by cosine squared. Cosine divided by cosine, sine divided by cosine, 1 divided by cosine. And there you have 1 plus tan squared is secant squared. How do I find the other one? Well, if we divide it by cosine squared, we can divide by sine squared. So cosine over sine squared, cotangent squared. Sine over sine, 1. 1 over sine, cosecant squared. And there are your three identities. Now, you can move these around algebraically, so don't let that intimidate you. And what I mean by that, if I've got cosine squared plus sine squared is 1, well, I can subtract cosine from both sides. And I can say, okay, sine squared theta is 1 minus cosine squared theta. There's no magic going on here. It's just basic algebra, so don't let that intimidate you. We're just moving the pieces around. I could also say, well, let's see what else I could do. I could also say cosine squared theta, whoops, sorry. I got ahead of myself. I can say cosine squared theta minus 1 is negative sine squared theta. No big deal. Again, I'm just moving the 1 to the left and the sine squared to the right. And you can do the same thing with sine squared theta minus 1 is negative cosine squared theta. Now, I've warned you about this ninja negative. This is the time you really need to pay attention to him, because what's so tempting to want to do is say, oh, okay, cosine squared theta minus 1 is sine squared theta, and you're going to forget that negative. So be very careful that you don't leave him out of the equation. Now, that's just one of the ways. I'm going back to your notes. So I've got 1 plus tan squared theta is secant squared theta. Again, you can move this all around. You can say 1 minus secant squared theta is negative tan squared theta. You can say tan squared theta minus secant squared theta is negative 1, moving the secant to the left and the 1 to the right. You can say secant squared theta minus 1 is tan squared theta. So I'm not going to harp on that too much. It's just algebra. So when should the bells be going off in your head? If you have the number 1 and your trig identity is squared, it is probably one of your granddaddy equations. Probably one of your granddaddy equations. And that's when you need to be thinking about that. Now, I realize you don't know yet where we're heading, but you will. These are just tools for you. So let's look at our basic identities. All right, cosecant, 1 over sine. Secant, 1 over cosine. Now, you'll notice we have cotangent written twice here. Well, In the first case, with my reciprocal identities, cotangent is 1 over tangent. Well, let's step here into the middle. Tangent is also an identity, and it's a ratio identity. And so what ratio is it? Well, of course, it's sine theta over cosine theta. So cotangent is the reciprocal of that. So not only can I write cotangent as 1 over tan, I can also write it as cosine over sine. So the cotangent has 2 different personalities. And then our granddaddy equation, a squared plus b squared is c squared, x squared plus y squared is r squared, cosine squared plus sine squared is 1. Well, there's 2 other identities that come off the granddaddy. If you don't memorize them, don't worry about it. You have to memorize how you can find it. How can I find the first one? And again, the tools are right here. Once you have cosine squared plus sine squared is 1, you have all the tools you need. What if we divide by cosine squared? Cosine divided by cosine is 1. Sine over cosine is tangent. And 1 over cosine is secant. All right? The other identity that comes off the granddaddy, well, I divided by cosine squared, so now I'm going to divide by sine squared. Cosine over sine is cotangent. Remember, it's square. Oh, I keep getting ahead of myself, sorry. I just changed that into a plus sign. Sine divided by sine is 1, and 1 over sine is cosecant squared. Okay, so these are the tools in your toolbox. Let's start seeing what we can do with them and how we're going to work through all this. Use the basic identities to simplify each of the following to a single trig function or a single number. Okay, so sine theta times cotangent theta. What I'm going to do, I'm going to say, okay, I have sine theta over 1. And why would I do that? Well, I know cotangent is, I know that cotangent is, I'm sorry, I just lost my train of thought, cosine over sine. So I'm going to turn them both into fractions. So I have cosine theta over sine theta. So that's what I've been presented. Well, if I'm multiplying fractions, right? Isn't that just going to cross out? So sine theta cotangent theta can be written as cosine theta. All right? Let's look at the next one. Sine squared theta over cosine theta times cosecant theta. That's a lot. So think this through. First of all, I'm seeing sine squared and I'm thinking granddaddy identity. But if I plug in 1 minus cosine theta, that's really not going to help me. So what I'm going to do, I've got sine theta times sine theta over cosine theta times what is cosecant theta? Of course, it's 1 over sine theta. Sine times sine is sine squared. Oh, okay, well, here we go. I can cross that out. And now I simply have sine theta over cosine theta. But I'm looking for a single trig identity or number, and sine over cosine is tangent theta. All right, heading to the back. Now, we just went from, yeah, not so bad to, oh my goodness. Okay, well, let's look at this. Problem 3, I'm already on alert with this because I've got my trig identity is squared and the number 1 is in there, which probably means this is a granddaddy. So what I'm going to do, I'm going to remind myself cosine squared theta plus sine squared theta is 1. I'm going to divide granddaddy by cosine squared, so I'm going to have 1 plus tangent theta is secant theta. And I'm going to divide it by sine squared theta. So I've got cotangent theta plus 1 is cosecant theta. So now I've got all my reference materials right there. All right, well, cosecant is what it is. So cosecant for now. But this 1 minus cosine is really suspicious to me. So I look up here. Well, if I move the cosine squared to the opposite side, 1 minus cosine squared is sine squared. Huh. We're making some progress here. So what is cosecant theta? Well, isn't that 1 over sine squared? And since that's a fraction, I'm going to make sine squared a fraction. And now those cancel out. And cosecant theta times 1 minus cosine squared theta, cosecant squared theta times 1 minus cosine squared theta is simply 1. And the number 1 is much easier to work with than all of that. All right, let's look at the next one. No squares in here, so let's just start by starting. And I think what we ought to do first is, I'm looking in here and I realize I'm going to have 1 over sine minus sine over 1, and that's not really going to help me. That's just going to introduce a rational, which, yeah, okay. If we could avoid it, we'll try. So let's do sine times cosecant. So we have sine x cosecant x minus sine times sine, sine squared x. Okay, again, we've introduced sine squared x. Again, we're thinking, oh, I wonder if the granddaddy equation is going to come in here somewhere. Well, let's just keep going. Sine is what it is, and cosecant is 1 over sine. Remember, we're trying to solve to one number or one trig function. Well, sine times cosecant is going to give me 1. 1 minus sine squared. I didn't mean to draw that, sorry. And again, of course, the piece that wipes off is the one that I was trying to cover. 1 minus sine squared. Let's come back up here to granddaddy equation. 1 minus sine squared. Well, if I move the sine squared to the right, this leaves me cosine squared x. So sine times cosecant minus sine is simply cosine squared x. All right, you ready? Let's go. Let's look at 6. Cotangent squared over 1 plus cosecant plus sine cosecant. Oh boy. All right, so first of all, let's see what we recognize here. I'm not going to worry about the cotangent squared theta yet, because the denominator isn't squared. The numerator may be part of the granddaddy, but the denominator is definitely not. But I do know sine theta times 1 over sine theta. Okay. So now I've got cotangent squared theta over 1 plus cosecant theta plus 1. And now I'm really thinking granddaddy equation needs to be introduced here, because I've got a square, a trig function squared, plus or minus 1. So if I run back up to the top here, I know that cotangent theta can be written as cosecant theta minus 1. Well, think about that for a second. If we introduce cosecant theta minus 1, now we've got the same terms in the numerator and the denominator. So this may make our life easier. Let's see if it does. So I'm going to change cotangent theta, squared theta, to cosecant squared theta minus 1. Huh. Well, isn't cosecant squared theta minus 1 difference of squares? Wouldn't that be cosecant theta minus 1 cosecant theta plus 1 over 1 plus cosecant theta? let's see. Cosecant times cosecant, cosecant squared, positive, negative, those go away, minus 1, there you go. So I can factor that. And when I do that, I've got the ability to cancel out cosecant theta plus 1. So now I'm left with cosecant theta minus 1 plus 1. Of course, the 1s are going to cancel out, and this entire thing boils down to cosecant theta. So if I'm looking at problem 5, I could write cotangent squared theta over 1 plus cosecant plus sine times cosecant, or same value, cosecant theta. All right. You may need to rework that one a couple times. Let's look at 6. I'm trying to write sine theta minus 1, sine theta plus 1 as a single trig term. Well, I can't cross anything out here, and I can't cross anything out here. But I'm seeing the number 1 and the potential to have sine squared theta, which leads me back to granddaddy. So here we go. Sine times sine, sine squared theta. Plus, minus, they disappear, minus 1. Sine squared theta minus 1 is, or can be written as, be careful here, negative cosine squared theta. And there's my answer. Okay. If you have your assignment 4.1, take that out. We're going to talk about that. Mm-hmm. Parker Fuege. Uh-huh. Hi, guys. Are they asking a question or just checking in?
Call it just checking in.
Okay. Oh, that's scary. That's what I was looking for. All right, y'all, let's go. Simplify each expression to a single trig function or number. So I've got secant sine. All right. Secant is 1 over cosine times sine over 1, which is going to give me sine over cosine. So I can rewrite secant sine as tangent theta. Okay. Let's look at problem 3. Tan squared minus secant squared. Okay. So again, now I'm thinking granddaddy, of course. So, I should have written this down at first, but let's write granddaddy. So I've got cosine squared theta plus sine squared theta is 1. The first variation of that is, and the second variation, take just a second and write that down, and I'll put the answer up in just a moment. Okay, so I want to keep that handy, because I'm going to need to refer to it. So I've got tangent squared theta minus secant squared theta. So as I'm looking at my granddaddy equations, well, there's tangent and secant in the same equation. So if I move secant to the left and negative 1 to the right, this whole thing can be written as negative 1. And there's really no work to show on that. You know it or you don't. And you do, so that's all you got to do. All right, let's look at 5. 1 minus cosine, 1 plus cosine. I've got to write this as a single trig expression. Okay, again, what's coming to mind? Granddaddy, because I've got 1 plus minus minus cosine squared. Be careful with the ninja negative. 1 minus cosine squared, is that going to give me positive or negative? Well, the sign's staying where it is. So 1 minus cosine squared can be written as sine squared theta. Okay? Take just a minute and do 2, 4, 6, and 8. We'll come back to 7 in just a minute. But do 2, 4, 6, and 8. Let's take, I don't know, 3 or 4 minutes. Excuse me. Just do 2, 4, and 6. I want to walk you through 8 together. Okay, let's see how you did. So I changed tangent to sine over cosine, cross out the cosine, I'm left with sine. 1 minus cosine squared, granddaddy identity, sine squared, no work to show. And secant squared minus 1, also granddaddy identity, tan squared. When you have the trig equation squared and the number 1 involved with it, it's probably one of your granddaddy equations. Keep that in mind. Now, in this case, let's see what's happening here. I've got the number 1 and I've got the squares. Excuse me. So what I'm going to do, let's just work on the sine squared over tan squared theta. Remember, these are rationals. So I've got sine squared theta over 1 divided by sine squared theta over cosine squared theta. Now, I'm just ignoring the number 1 for the moment. So what am I going to do? Well, I'm going to flip and multiply. So I've got sine squared theta over 1 times cosine squared theta over sine squared theta when I flip this into the numerator. Excuse me. My sine squares are going to cancel out. And now I've got 1 minus cosine squared theta. 1 minus cosine squared theta. Granddaddy equation, that gives me sine squared theta. We agree? Okay, let's go on. How much time do we have left? Yeah, we got time. I'm not ignoring number 7. I just don't want to do it remotely right now. All right, let's look at 9. 1 over cosine squared minus 1 over cotangent squared. And again, just to keep on track, cosine squared theta plus sine squared theta is 1. 1 plus tangent squared theta is secant squared theta. And dividing by sine squared. Cotangent squared theta plus 1 is cosecant squared theta. My 3 identities. So as I'm looking through this, I know that 1 over cosine is secant squared, and 1 over cotangent is tangent. So that's going to introduce tangent and secant squared. And those all go together in this identity. So I'm going to rewrite 1 over cosine squared as secant squared theta. 1 over cotangent is tangent squared theta. So now I've got secant squared theta minus tangent squared theta. Again, go to that identity. This whole thing is the number 1. All right. Let's look at 11. Cosine squared theta times secant squared theta minus 1. Well, you have 2 options here. Secant squared theta minus 1 is tan squared theta. And tan is sine over cosine. So that might be a good path to take. Let's try that. So I've got cosine squared theta times tan squared theta, which gives me cosine squared theta over 1 times sine squared theta over cosine squared theta. Of course, your cosines are going to cancel out, and you're left with sine squared theta. Okay, let's say you didn't take that path, because there's multiple ways to solve these. Let's say instead of recognizing that the secant squared theta minus 1 was tangent, let's say you distributed the cosine squared instead. Because you recognize cosine squared secant is going to be 1, so now you would have cosine squared theta, or A, I'm sorry, minus cosine squared. All right. Cosine times secant, and again, you can probably see this, but in case you can't, all right. Of course, cosine over 1 times 1 over cosine crosses out to 1, and now I have 1 minus cosine squared theta, and 1 minus cosine squared theta is sine squared theta. So there are multiple routes you can take to get to the same answer. And that's what gets frustrating, because sometimes you're not really sure if you're going down the right path. You'll know. All right, let's look at 13. Sine x cosine x over 1 minus cosine squared x. Okay, well, a little frustrating because I can't, sine and cosine don't multiply together to give me anything that's going to be helpful, but 1 minus cosine squared, again, that's that granddaddy identity. 1 minus cosine squared is going to be sine squared. And why is that important? Well, because what that gives me, look, now I have sine x cosine x over sine squared x, which means I can cancel out one of the signs. That goes away and one of those goes away, leaving me with cosine over sine. Okay, now it makes sense. That whole thing boils down to cotangent. All right, take 30 seconds. I'm getting on the clock so I can see what we've got going on here. Hang on just one sec. All right, take 30 seconds and do problem 10. And then I'm going to jump back in with you to do, depending on how much time we have, 12 and 14. But let's take 30 seconds and do 10. All right. Here's what I did. First of all, I don't have any identities in there, any granddaddy identities. So I'm just going to go ahead and distribute the cosine. I can't rewrite this. I could rewrite secant, but that's not going to help yet. So I've got cosine secant minus cosine squared. I know cosine times secant gives me 1. Now 1 minus cosine squared. Again, there's my granddaddy identity, sine squared. All right. I want to look at, hold on one second. We've only got 4 minutes left. We're going to revisit 12 when we have time, but let's look at 14 right now. Tan squared theta over secant plus 1 plus 1. That tan squared, let's jump up and look at our granddaddy. Tan squared can be secant squared theta minus 1. Well, if I introduce that, now I've got all secant in the equation. So let's just start there. Let's just take that path. So I've got secant squared theta minus 1 over secant theta plus 1 plus 1. Again, we've got a squared minus b squared. We have difference of squares. Secant squared theta minus 1 can be factored. So now we've got secant theta minus 1, secant theta plus 1 over secant theta plus 1 plus 1. Well, how perfect is that? That goes away and that goes away. So now we're left with secant theta minus 1 plus 1, or simply secant theta. Okay, here we go. I'm going to get a different sheet of paper for 12. We should have time to finish this. I'm almost sure we do. Let's go. I've got 1 minus cosine x, 1 plus secant x, and cosine x. Well, let's just start at the beginning and multiply these two together. So we have 1 plus secant x minus cosine x minus cosine secant. And all of that is times cosine. What do you know about cosine secant? Well, this is going to be 1. So now I have 1 plus secant x minus cosine x minus 1 times cosine x. This changed into 1. All right. Well, 1 minus 1, of course, is 0. So now I've got cosine x times secant x minus cosine x. You should see what's about to happen. Cosine times secant minus cosine squared, 1 minus cosine squared. This entire equation boils down to sine squared x. And that's, again, using that granddaddy identity to help us with that. Okay, I think our time is up. So what we're going to do, if you want to, try problem 7. See how it goes for you. We won't be recording tomorrow, but we'll be back on Wednesday, and we'll continue with this same topic. All right, y'all have a great day. Thank you.